Green hydrogen. Green hydrogen is a term that has been floating around in the news and also technology media for quite a bit. But what actually is green hydrogen and how do we get it? Well, we get green hydrogen via a process called water electrolysis. For water electrolysis, we first of all need a cell. That cell is filled with a fluid, usually water. And within that cell, we have a separator. The separator is there so that we separate our gases that we will produce from each other. Within that cell, there is further two electrodes, which are made from metal, and those electrodes are connected to a power source. Now, if we want to make green hydrogen, our power source would be, in this case, renewable energy, usually from the grid. But it can also be directly connected to renewable energy. Now, those electrodes and also the separator itself, the membrane, are within a fluid called the electrolyte. Since we're doing water electrolysis, in this case, our electrolyte will be the water itself. And using the power and the electrodes, we will be making hydrogen as well as oxygen. Now, how does this chemical process of electrolysis actually work? Let's take a look a little bit closer. Now, on the one side, we will have on the left here the cathode. The cathode is usually, in this particular case, an electron-rich, a negative electrode, while on the other side, we will have the anode, which is usually depleted of electrons and thus positive. Now, since we are feeding electrons from the power source to the cathode, we will have a reaction taking place on the interface between the fluid and the electrode, where protons, which are part of the water, will basically take up the electrons and are getting reduced to the green hydrogen we want. And the green hydrogen then forms bubbles, and the bubbles leave the system. Now, in this case, the water will actually go through the separator, here the membrane, and the water on the other side, on the anode, on the interface, will again conduct a reaction. Now here, the water itself is oxidized, or in this specific case, the oxygen is oxidized, thus forming oxygen gas, and we'll also obtain a couple of electrons as well as two protons. Now, the electrons will go back to the power source because everything here needs to be perfectly balanced. Everything needs to be in equilibrium, while the protons will actually go to the other side of the membrane and be consumed by the cathode again. And thus, we will have our water electrolysis process. Everything is balanced and we obtain green hydrogen and also oxygen as well.